What if I told you, a handful of wet dirt changed the destiny of an entire bird family? Swallows, martins, sawwings, belong to the Hirundinidae, sleek aerial acrobats, best known for building nests out of mud, sticking them to cliffs, bridges, and your porch light. But how does a bird that spends most of its life in the air become a miniature architect with a mortar mixer for a beak? Let's start with the problem a nest solves. A nest is safe and stable. Dry. To keep eggs warm and chicks alive. For early hirundines, there were a few options. Dig burrows in sandy banks like the sand martin, find tree cavities like the tree swallow, or stick something to rock. Mud is abundant after rain. Moldable, and surprisingly strong once it dries, especially when reinforced with grasses and glued with saliva. So how does mud building evolve? Think small steps. Imagine ancestors that already gathered wet material to line a cavity. If a pair starts plastering a bit of mud on a ledge to keep eggs from rolling, that's a tiny advantage. Their chicks survive a little more often. Over generations, selection favors birds that collect stickier mud, add fibers, and place it on better overhangs. What starts as lining becomes a rim, then a cup, then a fully enclosed gourd with a tunnel, like the intricate colonies of cliff swallows. Different lineages took different routes. Sand martins still excavate burrows, great in soft banks but useless on bare rock. Barn swallows craft open mud cups on beams, ledges, making the most of human structures. House martins build enclosed mud spheres tucked under eaves, reducing predators and rain. Sawwings in Africa attach compact mud cups to rock faces under waterfalls, and overhangs where spray keeps predators away. The family map reads, like an experiment nature ran in parallel, with mud as the constant and structure as the variable. Why mud at all? 3 big reasons. First, safety. A vertical wall under an overhang is hard for snakes and mammals to reach. Second, climate control. Thick mud walls buffer temperature swings and shed light rain when placed under a drip line. Third, efficiency. For an aerial insect hunter, flying back and forth with beakfuls of mud is actually energy cheap compared to hauling sticks, and after storms, the material literally appears at your feet. There's also culture. Young swallows watch adults. They learn where to collect the right consistency, just enough clay to hold, just enough straw to bind. They copy how high to build and how to wedge nests into texture on the wall. These learned tweaks get refined by natural selection. If a style resists parasites better or keeps eggs from falling, those parents leave more offspring. Humans accidentally turned the dial. Bridges, culverts, barns. Stucco gave swallows millions of ready-made cliffs. Species like barn and cliff swallows exploded across continents, timing construction with rain so fresh mud sets before dry spells. Their saliva even acts like a protein glue, helping each pellet lock in as it dries. Think tiny adobe bricks with built-in paste. Do we see the transition in the fossil record? Not really. Mud nests don't fossilize well, but genetics and behavior suggest the ancestral hirundine likely used cavities or burrows, with mud building evolving multiple times, and becoming more elaborate in some branches. In other words, it's a behavioral toolkit, shaped by place and opportunity. So next time you walk under a bridge and hear that cheerful chatter, look up. You're witnessing an evolutionary success story held together by water, earth, and spit. Simple materials, brilliant engineering, and behavior fine-tuned by generations. If this sparked your curiosity, hit like, subscribe, and tap the bell. I've got more bite-sized deep dives coming because the everyday world is full of ingenious design hiding in plain sight. See you in the next one.